Hello everyone and welcome. In today's interesting physics class, we are going to talk about dimensional analysis. And we have a very interesting question before us. Let's read and solve it together. The question reads, the period t of a soap bubble under simple harmonic motion is given by t is equal to p raised to the power of a density of rho raised to the power of b and surface tension raised to the power of c, where p is the pressure, rho is density, and s is surface tension. Find the values of a, b, and c using dimensional analysis. How do we solve this problem? To someone who has no knowledge of physics or dimensional analysis, it looks very challenging, but trust me, we can always have our way around this problem. How do we do this? The first thing that we have to do is to identify the given parameters or variables in the question. You can see that we are going to find the value of these powers, A, B, and C. Okay, now the first thing that we have to do is to identify the given variables. Here we have T. T is for time. This is pressure. Here is density. And lastly, we've got surface tension. Having identified the given variables in the question, the next thing that we have to do is to determine their dimensions. That's the next thing to do. Now, how do we find their dimensions? To find the dimensions, we need to know either their units or their formulas. With either of these two, we can determine their dimensions. For the left-hand side, we have a t. Let me write it this way. We have a t. So we use the MLT system. MLT system, okay? Now, in physics, we have what we call 7 fundamental quantities. And they're as follows. We have mass, we have length, we have time, we have electric current, we have temperature, amount of substance, and luminous intensity. However, when doing dimensional analysis, we mostly use mass, length, and time. Okay? Now, this M here represents the dimension for mass, the L represents the dimension for length, and the T represents the dimension for time. Now, when you look at this part, you can discover that we only have T on the left-hand side. Now, what's the dimension for T? The dimension for T is simply T, okay? The dimension for time is simply T, but let's write it a little bit more, let's be a little bit more technical in this case. So we can say that the dimension for time is M to power 0, L to power 0, and then T. This T is to the power of 1. I have not changed anything yet. Remember that any number raised to the power of 0, apart from 0, is simply 1. Now, for me to raise m to the power of 0, it means that this m is simply a 1, and they are multiplying, right? Now, this L to the power of 0 is also a 1. So 1 times t is just a t. Okay? I'm going to explain why I'm doing this and why it's important to do it to avoid forgetting, because we are actually going to arrive at simultaneous equations which we have to solve simultaneously in order to determine the values of A, B, and C. And for whatever you have on the left-hand side, please ensure that to include the M, L, and T, because if you include only the T, when it comes to equating their powers, you might get stuck. We'll see that when we start solving the problem. Now, the dimension for time is simply m to the power of 0, L to the power of 0, and T. The dimension for time is still T, okay? It's just a T, but we want to make this appear in a better way to avoid making mistakes. Now, having found the dimension for time, let's now find the dimension for pressure. How do we find the dimension for pressure? We need to understand that I said that we can find these dimensions in two ways. The first one is using the units, and the second one is their formulas. And I'm going to prefer using their formulas right now. So pressure is defined as force over area. Okay? Now, force is given as a formula F is equal to ma. Okay? So this is force over area. And then for force, the formula is mass times acceleration, right? Okay, so let's find the dimension for force first. The dimension for mass is m, so we put an m here. The dimension for acceleration is what? Okay, acceleration we do not know, but let's try to find the dimension for acceleration. Acceleration A is defined as the rate of change of velocity with respect to time. If you can remember these formulas, then you have no problem with finding or deriving their dimensions. Acceleration is said to be the rate of change of velocity, which is delta v over delta t. The rate of change of velocity with respect to time, right? Now that means that we need to also know the dimension for velocity in this case. Okay, for us to find the dimension for acceleration, then when we find the dimension, we can now put it here. So what's the dimension for velocity? We know that velocity is equal to the rate of change of displacement with respect to time. So when we say displacement, displacement is simply length and it is measured in meters. Now what is the dimension for length? The dimension for length is simply L. So that means that right here, wherever I see x, I'm going to replace it with its dimension. Remember that x is measured in meters, and meters is length. The dimension for length is simply L. Okay, remember here means mass, length, and time. Now this now gives us L over the dimension for time is simply t. Now I can rewrite this to be in a better way by moving the t to the top. Remember that if it's down here using uh, the reciprocal rule of exponents. For example, if you have 1 over a, remember that this a here has a power of 1. If you take it upwards, it now becomes a minus. Hence, we now have a to the power negative 1. Okay, now this t down here has a power of 1, a positive 1 below. If we take it upwards, it now becomes lt minus 1. And that means that the dimension for velocity is equal to Lt minus 1. Let me write this properly. Velocity is equal to Lt to the power negative 1. Remember that we're still looking for the dimension for acceleration. Okay? Since we said that acceleration is the rate of change of velocity with respect to time. Now let's do that properly. Here we have that acceleration is equal to the dimension for velocity is Lt minus 1 over the dimension for time, which is this one here, is just a t. Okay, now let's solve this properly to avoid confusion. So using the same property that I use right here by taking the t from the denominator to the numerator, or by removing it from the denominator, we also do the same here. Remember that this t has a positive power of 1, and when we take it upwards, it now becomes a negative. Hence, we now have Lt minus 1, and then the one we take upwards will now also become t minus 1. All right, remember that they are all multiplying. At this point, we have to apply the multiplication law of exponents that says when you have like bases, for example, a squared times a to the power of 3. A is a base. A is a base. 2 and 3 are their exponents. It says when you have like bases that are multiplying each other, you simply add their powers. So this now gives you a 2 plus 3, and this is a to the power of 5. We also apply the same concept here by adding their powers. Hence, we now have that the dimension for acceleration is equal to, here we have t, okay, t and the t are the same bases. So this now becomes Lt. Now you add them, minus 1 plus minus 1, okay? Minus 1 plus minus 1 is like when you have minus 1 minus 1, it gives you minus 2. So minus 1 minus 1 gives you minus 2. In that case, the dimension for acceleration is now equal to LT minus 2. All right. So we can now substitute to see what we can get. We've already found the dimension for acceleration, which is LT to the power negative 2. Remember that we're looking for force, right? We're looking for the dimension for force. We've already found the dimension for mass, and now we now have our acceleration. So let's now substitute. We said that F is equal to ma. So this is equal to the dimension for mass is just m. We have now determined the dimension for acceleration to be lt minus 2. We now write lt minus 2. Therefore, the dimension for force is now equal to mlt to the power negative 2. Okay, good. But remember that we're looking for pressure. This is a very long process. But if you understand how to determine their dimensions, then no matter how the question is twisted, you'll be able to understand it, or you'll be able to answer it. All right, so for area is measured in meters squared. Okay, so we have that area is measured in meter squared. Now, what is dimension for length? Remember that meter relates to length, right? So length is measured in meters. And in that way, we can say that the dimension for length, since length is measured in meters, right? So this now becomes area is equal to length. Remember that meter is the SI unit for length. So this now becomes, and the dimension for length is L, and we now have L squared. Okay, remember that this one is at the denominator. You can see it here. That pressure is equal to force over area, right? Correct. So this we now say that pressure P is equal to force over area. Now, what's the dimension for force? We've determined it to be MLT minus 2, okay? MLT minus 2 over the dimension for area, we've determined it to be L squared. This now becomes over L to the power of 2. Now, we also apply the same concept by taking the L squared away from the denominator. And when we take that away, remember that this power here is positive, and when it goes upwards, it becomes a negative. Hence, we now have MLT minus 2, and then L, okay, minus 2. Correct. So let's make this better. How do we do it? We say that pressure is equal to, here we have the mass, which is the M. I'm going to rearrange this. Remember, it's written in the form of MLT. So the M comes first, followed by L, and then the T comes last. Okay, so here we have L. I'm going to rearrange them. This is the first L to the power of 1 times the second L to the power of minus 2. And finally, we have our T to the power negative 2. Okay, I did not change anything. I only put this with this, and then the T now comes last. Now, let's also apply the same laws of exponents that says if you have like bases that are multiplying, you simply add their powers. Now, this one here is the power of positive 1, right? Now, 1 plus negative 2, just like when you say 1 minus 2, right? Now, 1 plus negative 2 gives you negative 1, okay? So we now say M, L, okay, 1 plus minus 2. And then you also have T minus 2. So let's clean this up. The dimension for pressure is now equal to M, L. So minus 1, or 1 plus minus 2 gives you minus 1. Like I said, it's just like when you have 1 minus 2, it gives you minus 1. And finally, T minus 2. So this is the dimension for pressure. That's how to find the dimensions, okay? Okay, but now it's going to be quite easier because we've already done a lot of work. Let's now go to density, okay? Let's go to density. Density, the dimension for density is defined as mass over volume. We need to know the definitions or formulas. It's really very important. And then the dimension for mass, we know that the dimension for mass is just m over the dimension for volume is meter cubed. Okay, let's just do this, meter cubed, right? So volume is actually defined to be length times breadth times height. And remember that meter is the dimension for length, and a meter is the SI unit for length. And the dimension for length is just L. So we now say that this is equal to M over, since it is cubed, our dimension for volume will also be cubed. And this now becomes L cubed. So if you take the L cubed to the top, it now becomes a negative. We now have M L to the power minus 3. Okay, so that now means that the dimension for density is equal to ml to the power negative 3. Okay, so we have now found the third one. And lastly, we have the last one to be surface tension. Surface tension. So surface tension, the dimension for the formula for surface tension is force over length. And we have already found, remember I told you that you need to know their formulas. It's really very important. Knowing their formulas or definition gives you a clue on what the dimensions are, even if you don't know the units, right? Good. Now, let's now go ahead and substitute. Since we've already determined the dimension for force, see it here? Dimension for force is mlt minus 2. So whenever we see force right now, we put m LT minus 2. Okay, so this is all over, this is length, right? It's force per unit length, or force over length. And the dimension for length is just L. We also take it upwards. Remember that this L has the power of 1, right? When we take it upwards, it now becomes M L T minus 2, and then we have L minus 1. Okay, correct. Let me do it, let me simplify it in a better way. We have that the dimension for surface tension is now equal to, I'm going to rearrange this just like I did for the one we did previously. This L, I'll bring it to this place. So we now have M L. Remember that this is a positive power 1. And here we have another one to be negative 1. And lastly, T minus 2. So this is equal to, remember the law says if the bases are the same, this is an L, this is another L, they are the same. So what do? You simply add their powers. So this now becomes 1 plus minus 1, which gives you a 0. Or you can say 1 minus 1, it is still correct. So 1 minus 1 gives a 0, and you now have m L to the power of 0, and then T minus 2. So this is equal to, remember that any number raised to the power of 0 apart from 0 is simply 1. And then 1 times m and t gives you the same value. Hence we have m t to the power negative 2. Therefore, the dimension for surface tension is equal to m t to the power minus 2. So this is how to get dimension of any quantity you want. It's either you know their formula or their units, but I prefer using their formulas because it makes it easier for me. So let's now list them out. The dimension for time is equal to m to the power of 0, L to the power of 0, and then t. The dimension for pressure was determined to be, let me go back to check it. We had it here to be m L minus 1 T minus 2. Yeah, T minus 2. Not a positive 2. ml T, okay. ml minus 1 T minus 2. So for pressure, we say ml minus 1 T minus 2. The next one there is density. Density, the dimension is m L minus 3. And lastly, surface tension is said to be m T minus 2. Okay, we found all their dimensions. And having found this, we can now do this. We now say we have to open a bracket. So whatever we see, or let me copy down the equation again. So the equation here says T is equal to the hydrostatic pressure raised to the power A, the density to the power of B, and surface tension to the power of C. Now, let's now solve it together. Wherever I see T, I'm going to substitute the dimension for T. Hence, we now have M to the power of 0, L to the power of 0, and then T. Okay? Good. So this is equal to, wherever I see P, I put the dimension for pressure, which is M, L minus 1, T minus 2. Hence, we now have M, L minus 1, T minus 2. But remember that they are all raised to the power of A. So we also raise it to the power of A. And the next one here is density. The dimension for density is M, L minus 3. And this would also be raised to the power of B. Lastly, we have the dimension for surface tension, which is M, T minus 2. And this is also raised to the power of C. Now, the next thing to do right here is to distribute the powers, okay? We have to maintain the left-hand side, but we are going to distribute the powers. You can see that this is to the power of A. So this A goes to the M, it goes to the L, it goes to the T. This B goes to the M, goes to the L. This C goes to the M and also goes to the T. So that's how we distribute them. On the left-hand side, we maintain what's there. We now have M to the power of 0, L to the power of 0, and then T. This is equal to, so M and A gives you M to the power of A. Then minus 1 times A gives you L to the power minus A. And for the T, minus 2 times A gives you T to the power minus 2A. Now let's do for the B. Here we have, this is the power of 1, right? So 1 times B gives you M to the power of B. And then negative 3 times B gives you L to the power minus 3B. And lastly, let's do for this one that's remaining. So this is M to the power of 1, right? So 1 times C gives you M to the power of C. And then this, we have a negative 2 here times C. This gives you T to the power minus 2C. Okay, we have distributed everything. Now, the next thing I'm going to do right now is to rearrange them and put them in the form of MLT. Okay, it's MLT system. So they must be in this very form. I'm going to arrange them by bringing the mass together. Okay, I'll put the mass first. Put the mass first, then next length followed by the T. We maintain what's on the left-hand side as well. And we have M to the power of 0, L to the power of 0, and T, this is equal to, so I'll pick this M. We now have M to the power of A. Pick this M again. This gives us M to the power of B. And I'll pick this M here. We now have M to the power of C. Now let's pick the L. I'll pick this first L. We have L to the power of minus A. The next L, okay, L to the power of minus 3B. And then we are done with the L's, right? Okay, correct. So let's now go ahead and pick the T's. We have the first T here to be T to the power of minus 2A. And then the next T remaining is now T to the power of minus 2C. Okay, so having done this right now, what do we do? Remember that I said if the bases are the same, you simply add their powers. Since they're multiplying, the M, this is M times M times M. This is L times L. This is T times T. So we simply add their powers since their bases are the same. We still maintain what is on the left-hand side. So this is M to the power of 0, L to the power of 0, and then T. Remember that this is to the power of 1, right? Correct. So this is equal to Since the bases are the same, we simply add the powers. We now have m a plus b plus c. Okay, they are the same bases, so we add their powers. Now the next one is L. This now becomes minus a minus 3b. Correct. Now let's add for the t. This becomes t minus 2a minus 2c. Correct. Okay. Now, what's the next thing that we're going to do with this very information? We have to understand that we have this law in exponents that says if you have, for example, 4 raised to power x is equal to 16. Okay? So what this means is that what number do I need to raise 4 to? Okay? What number do I need to put here that when I raise 4 to that number, I'll get a 16? Okay? Now, if you want to solve this very problem, we know that 4 raised to power 2 is equal to 16, but you cannot just guess that the answer is 16. So what do you do in this case? You simply say, okay, 16 can be written in the form of, here we have 4 to the power of x is equal to, 16 can be written as 4 to the power of 2, right? Correct. So what we do in this case is, since the bases are the same on both sides, we simply equate their powers. Okay, so if the bases are the same on both sides, this is the left hand side and here we have the right hand side, as long as they are the same, what you have to do is to equate the powers. So this means that the value of x is equal to 2, and that means that if we put 2 in here, okay, we're going to get a what? A 16. So that is what it means. And using the same concept right now, we are going to compare the powers, or we equate the powers on both sides. So I'm going to say equating the powers. Okay, so for the m, it's now going to be, okay, a plus b plus c is equal to 0. Look at this. Okay, the exponents or the powers of m on the right hand side is equal to a plus b plus c, and the power of m on the left hand side is 0. So I'm going to equate them by saying a plus b plus c is equal to 0, and this I'll call my equation 1. Now let's do for the L. The powers of L on the right hand side is minus a minus 3b, and the power of L on the left hand side is just a 0. Hence we now have minus a minus 3b is equal to 0. Now you've seen why I had to raise them to the power of 0 to avoid confusion. Because if they were not there, I might not remember, and that might end up causing me or forcing me to go blank in the examination hall. You see, so that's why. Now let's do for the t. The powers of t on the left, on the right hand side is minus 2a, okay, minus 2c. This is equal to what? The power of t on the left hand side is just a 1. So this is equal to 1. Okay, so this is our equation 2, and here we have our equation 3. Now, having done this, we can now solve them simultaneously to find their respective values. Remember, they say we should find the values of a, b, and c. Okay, so how do we solve this right now? You can see that equation 1 has a, b, and c. Equation 2 has a and b only, no c. Equation 3 has a and c only. That means that there is no b. So we can't solve the 3 of them at the same time by elimination. So what's going to happen is that I'm going to make b the subject in equation 1, and I will say making b the subject in equation 1. Okay, so we now say a plus b plus c is equal to 0. I'll make b the subject by moving the a and the c to the other side. Therefore, you now have b is equal to minus a, because this a is a plus here. If it goes to the other side, it now becomes a minus. Hence, we now have b is equal to minus a minus c. Correct. All right, so now I'm now going to substitute. Wherever I see b in equation 2, I will substitute this value Remember that we don't have a b in equation 3. We only have it in equation 1 and 2. And since I've made it the subject, I'm going to substitute the value of b. The value of b is minus a minus c. So wherever I see b in equation 2, I'm going to replace it with minus a minus c because that is the value of b. Now let's do that. Hence we have minus a minus 3, and then we open our bracket. Since the 3 multiplies the b, this now becomes minus a minus c. We close the bracket, and then this is equal to 0. Let's expand right now. Here we have minus a, then minus times minus gives you a plus. 3 times a gives you 3a. Now let's multiply further. Minus times minus gives you a plus. 3 times c gives us a 3c. And this is equal to 0. All right. So we can now collect like terms. Minus a plus 3a will give us a 2a. And then we have our 3c left. This is equal to 0. Correct. We can now call this our equation 4. Okay, have you seen right now that we have successfully removed b? Okay, and now we can now solve these two equations. We can now solve equation 3 and equation 4 simultaneously. So let me copy down equation 3. We have minus 2a minus 2c is equal to 1. Okay, so we have minus 2a minus 2c is equal to 1. Okay, so this is our equation 3. Okay, now what do we do right now? We can now use elimination method to eliminate a and solve for c, right? So what do we do now? Look at this here. Okay, we can add these equations. Okay, now this one here is 2a. In case you do not know how to solve simultaneous equations, I have a video on my channel that explains very well on how to solve simultaneous equations with 2 variables, 3 variables using elimination and substitution. Maybe you can check it out and that will help you understand it better. So we cannot add them. This one is a plus, this one is a minus, right? So 2 minus 2 gives you a 0, they go away. Now 3c minus 2c gives you a c, right? Now 0 plus 1 is equal to 1. And that means that c is equal to 1. So we keep that aside. We found the value of c. So c is equal to 1. Now, what's the next thing to do right here? We still have to solve for a and then b. Okay? Now, to solve for, okay, let's see which one to solve for. We only found our c. We can use equation 4 to solve for a, since we've already found our c. So this is our equation 4, right? Correct. So I'm going to say solving for a using equation 4. So what's the equation 4? The equation 4 is 2a plus 3c. This is equal to 0. All right. So no matter which one you use, even if you use equation 3, you still arrive at the same solution. So that means that wherever I see c, I'm going to put a 1 because c is equal to 1. Hence, we now have 2a plus 3 multiplied by 1 is equal to 0. So 2a is equal to, so 3 times 1 gives you a 3, right? Okay, so let's do it this way. Plus 3 is equal to 0. 3 times 1 is a 3. Okay, now we have 2a is equal to, I'm going to move the 3 to the other side. It now becomes minus 3. Now to solve for a, we divide both sides by 2. Divide both sides by 2. So this cancels out. We now have that our a is equal to minus 3 over 2. Correct. So this is the value of a. Now let's go ahead and solve for b. Let's solve for b. We can use equation 1 or any of these equations. So let's use equation 1 to solve for b. Okay. So we say solving for b using equation 1. So equation 1 is a plus b plus c is equal to 0. All right. So we determined our a to be minus 3 over 2. So wherever we see a, we put minus 3 over 2. This now becomes minus 3 over 2 plus b, okay? And then we have plus our c, we got it to be a 1. And hence we now have plus 1. This is equal to 0. Okay, correct. So now let's now move everything to the other side. Okay, we move everything to the other side to solve, to isolate and solve for b. So we now have that b is equal to, if this minus 3 over 2 goes to the other side, it becomes a plus. So we now have 3 over 2, and then this is a plus 1, right? If it crosses over to the other side, it becomes a minus 1. Hence, we now have 3 over 2 minus 1. But hey, this is a fraction. What do we do in this case? We just have to combine them into a single fraction by getting a common denominator, okay, for the two fractions. Therefore, we say that b is equal to, the common denominator between 2 and 1 is 2, right? Correct. So we now say the common denominator is 2. We now divide. 2 divided by 2 gives you a 1, or gives us a 1. And 1 times 3 is 3. Okay? Now, next up, 2 divided by 1 gives us a 2, right? And then 2 times minus 1 gives us minus 2. Okay? Or 2 times 1 is equal to 2. So let's now subtract them since we now have a common denominator. We now say that b is equal to 3 minus 2 gives us a 1 over 2. Hence, this is the answer, or this is the value of b. So we can now say that a is equal to minus 3 over 2, b is equal to 1 over 2, and then c is equal to 1. So these are the values that we're looking for. All right, thank you so much for standing by till this moment. In our next video, we're going to be solving problems on Stokes' formula and how to derive it. See you in the next video, and bye. I believe you understood this. If you have any questions, contributions, or comments, I'll be right in the comment section waiting for you. See you in the next video, and bye.